Some natural phenomena. Lesson preview. Lightning and static electricity. Electric charge. Types of charges and their interaction. Transfer of charge. Earthing. Lightning. Do's and don'ts during a thunderstorm. Lightning conductors. Earthquake and its occurrence. Protection against earthquakes. Rain, lightning, thunder, volcanic eruption, earthquake, storm, cyclone, etc. are examples of natural phenomena. Some of them are harmless, whereas others are destructive. In the previous class, you have studied about winds, storms, and cyclones. In this chapter, we will study about two other natural phenomena, lightning and earthquake. We will also study what steps we can take to minimize the destruction caused by them. Lightning and static electricity. In ancient times, people thought lightning was due to the divine wrath, but now we have the answer as to what causes lightning. Lightning occurs due to the accumulation of charges in the clouds. It is also a spark but on a massive scale. Way back in 600 BCE, Thales of Miletus, a Greek mathematician and astronomer, found that when a piece of amber was rubbed with fur, small pieces of hair, feathers, straw, etc. were attracted to it. You must have observed that when you take off your nylon and polyester clothes in the dark, tiny sparks of electricity are seen and a crackling sound is heard. You must have seen that when you rub a plastic scale or comb on your head and then hold it near some tiny pieces of paper, they get attracted towards the scale or comb. Pieces of paper getting attracted. Benjamin Franklin, an American scientist, conducted an experiment in 1752 CE using a silk kite. He tied a small metal key to the string held in the hand. When the kite flew into the clouds, lightning struck and the key turned hot. The key became electrically charged. He concluded that lightning and spark from our clothes are essentially the same phenomenon. Activity. Take a plastic refill and rub it vigorously with a piece of polythene. Now bring the refill near small pieces of paper. Repeat this activity using dried leaves, husk, straw, mustard seeds, etc. What do you observe? You will notice that things get attracted to the charged refill. Note: do not touch the rubbed end of the refill with your hand or with a metallic object. Electric charge. When the plastic refill is rubbed with a polythene piece, it acquires a small electric charge by friction. The object which acquires the charge is called the charged object. Static electricity produced by this method is called charging by friction. Activity. Let us charge various materials using the method of rubbing. Rub a balloon with a piece of woolen cloth or polythene. Bring the balloon near pieces of small paper. What do you observe? Similarly, repeat the activity with some more objects. Table. Object rubbed. Material used for rubbing. Material used for rubbing. Charged/not charged. Balloon. Woolen cloth/polythene. Attracted. Charged. Glass rod. Silk cloth. Attracted. Charged. Eraser. Woolen cloth. Attracted. Charged. Ebonite rod. Wool. Attracted. Charged. Hard rubber. Steel rod. Fur. No effect. Not charged. When a glass rod is rubbed with silk cloth, negative charges of the glass are transferred to silk. The glass rod acquires a positive charge and the silk cloth a negative charge. When ebonite rod is rubbed with wool, wool gets positively charged and ebonite rod gets negatively charged. Objects made of rubber, polythene, glass, and ebonite can be charged. Metals cannot be charged by rubbing. Hence, the comb and balloon are said to be electrically charged when rubbed against a polythene piece. They acquire electrical charge. These electric charges generated by rubbing are static, i.e. they do not move. These electric charges produce in them a kind of force which can attract as well as repel objects. We call this electrostatic force. Activity. Take two balloons and inflate them. Hang them on a cloth string in such a way that they do not touch each other. Rub both the balloons with a woolen cloth. What do you observe? The balloons move away from each other. Now repeat the experiment, using plastic refills and rubbing them with polythene. Place one refill in a glass tumbler after rubbing it. Bring the second charged refill close to this one. What do you observe? Do they attract or repel each other? Now repeat the activity with objects made of two different materials like a balloon and a plastic refill. What do you now notice? We can conclude that a charged balloon repels a charged balloon. Similarly, a charged refill repels a charged refill. However, a charged balloon attracts a charged refill. Types of charges and their interaction. From the above activity, it is clear that like charges repel each other, and unlike charges attract each other. Do you know it was Benjamin Franklin who also discovered that there are two kinds of electric charges, positive and negative charges, represented as plus or dash. The electric charges produced by rubbing are static, that is to say, they do not move by themselves. When the charge moves, it constitutes electric current. Do you know that you can only charge insulators with static electricity? Equal and opposite charges. When a glass rod is rubbed against silk, it acquires a positive charge. At the same time, the silk cloth acquires an equal negative charge. In case of PVC and wool, PVC gets a negative charge and wool gets a positive charge. Thus, when two bodies are charged by rubbing against each other, they acquire equal and opposite charges. Testing for charge. We have seen that a charged body attracts another body having an opposite charge. A charged body can also attract an uncharged body. So, attraction by a charged body is not an indication of a body being charged. However, if a body is repelled by a charged body, you can be certain that the tested body is charged, because uncharged bodies cannot be repelled by a charged body. Hence, to test if a body is charged or not, bring it near a positively charged body and a negatively charged body one by one. If it is attracted by both, it has no charge. Repelled by the positively charged body, it is also positively charged. Repelled by the negatively charged body, it is also negatively charged. Thus, repulsion alone is a certain test of whether a body is charged or not. Electric charges in atoms. When two bodies are rubbed together, where do electric charges come from? Electric charges are in fact present inside atoms. Each atom possesses particles with both positive and negative charges. In normal conditions, the number of particles with negative charges, electrons, in an atom is equal to the number of particles with positive charge, protons. So, the charges neutralize each other, making the atom electrically neutral. The positively charged particles are firmly held in the atom, while the negatively charged particles are loosely bound. It is possible to remove some of the negatively charged particles from the atoms by processes such as rubbing. Charging by rubbing. When a glass rod is rubbed against silk cloth, some negatively charged particles move from the glass rod to silk cloth. The result is that the glass rod is left with an excess of positively charged particles while the silk cloth acquires an excess of negatively charged particles. This is why the glass rod becomes positively charged and the silk cloth becomes negatively charged. This explains why two bodies when rubbed against each other acquire equal and opposite charges. Effect of rubbing glass with silk. Glass rod. Silk. Charging by conduction. An object can also be charged by touching it to a charged body. This happens because some charge from the charged body gets transferred to the uncharged body till both are equally charged. This is called charging by conduction. In this process, the body being charged acquires the same kind of charge as that on the charged body. Charging by induction. A body can also be charged by bringing a charged body near it, but not touching it. This is called charging by induction. In this process, the body being charged acquires an opposite charge to that of the body charging it. Transfer of charge. It is possible to transfer electric charge from a charged object to another through a metal conductor. Electroscope is a device that works on this principle. It is used to detect and measure electric charge. Activity. Take an empty jam jar. Cut a piece of cardboard slightly bigger than the mouth of the bottle. Make a hole in the center of the cardboard. Take a paper clip and open it completely as shown in the figure. Now take 2 strips of aluminium foil about 1 cm times 1.5 cm each. Hang them on the paper clip as shown in the figure. Charge a refill by rubbing on your hair and bring it near the end of the paper clip. What do you observe? The 2 foil strips repel each other. You can repeat the activity using different charged bodies like a refill, balloon, ebonite rod. At the start, the aluminium strips were not charged and they hung freely. When a charged refill was brought to touch the paper clip, the charge from the refill flows down to the foil strips. Metal is a good conductor of electricity, and the 2 strips repel each other as they now carry the same charge. An electroscope can thus be used to test whether an object is carrying a charge or not. If you gently touch the paper clip with hand, the strips come back to their original places. This is because the foil strips lose charge to the earth through our body. The foil is said to be discharged. Earthing. The process of transferring charge from a charged object to the earth is called earthing. You must have often heard the word earthing. Most electrical appliances and the electrical points in the house are earthed. This is done so that we may not get an electric shock. Lightning. Lightning is a spectacular sight in nature. You have studied in the previous class that air currents move upwards and water droplets move downwards during a thunderstorm. Due to this movement, the charges in the water molecules of the clouds separate in such a way that the positive charges concentrate near the upper edges of the clouds and the negative charges near the lower edges. These charges keep building up. Air, as we know, is an insulator. But when the magnitude of accumulated charges builds up, the insulating property of air breaks up and it is no longer able to resist their flow. The negative and positive charges meet, resulting in the production of streaks of bright light and sound. This process is called electric discharge. The process of electric discharge can occur between clouds and the ground or between 2 or more neighboring clouds. A large amount of electric current is produced during a lightning strike. This causes the air to heat up enormously and flashes of lightning are seen. The increase in temperature expands the air violently. This creates a sound, which we call thunder. Lightning can cause loss of life and property. It can damage buildings, burn trees, cause forest fires, and kill living things. We must therefore take safety measures to protect ourselves. Lightning safety. Rush to a safer place on hearing thunder. Wait before coming out of the safe place for some time after hearing the last thunder. Safe place. It could be a low-rise building or a house. If in a bus or car, close the windows/doors, and you are safe inside. Do's and don'ts during a thunderstorm. Outside the house, do not take shelter under trees. In case they get struck by lightning, there is a danger of getting burnt. Do not carry an umbrella during thunderstorms. If in a forest, take shelter under shorter trees. Stay away from tall trees, high-rise buildings, metallic objects, and poles. Open vehicles like bicycles, scooters, motorbikes and tractors are not safe. Open places, shelters in parks, etc. are also not safe. Do not run across a large open field or high ground. Do not lie down on the ground. It is better to squat low on the ground with your hands on your knees and head between your legs. Inside the house, unplug all electrical appliances like TVs, computers, etc. Do not use wired phones. It is better to use cordless phones or mobile phones. Try not to call a person who is receiving your phone through a wired phone. Avoid contact with running water and hence do not have a bath. Do not touch metallic objects like metal pipes, railings or electric wires. Lightning conductors. Lightning conductors are used to protect buildings from the damaging effects of lightning. It is a device which consists of a long copper rod with sharp spikes at its upper end. The lower end of the rod is connected to a large copper or aluminium piece buried deep inside the earth. The rod is taller than the building and is installed during the construction of the building. In case lightning strikes, the rod provides an easy path for the charge to pass through to the ground and the building remains unharmed. Earthquake. Earthquake is another destructive natural phenomenon. Scientists are still not able to predict it accurately. It causes great destruction to human life and property. What is an earthquake? An earthquake is a sudden movement or trembling of the earth which lasts for a brief period. It is caused due to a disturbance deep down inside the earth's crust. Earthquakes occur all over the earth all the time. They may range from mild tremors that are not noticed to massive ones causing widespread destruction and damage to buildings, bridges, dams, and life. Earthquakes can also cause floods, landslides, and tsunamis. You must have heard about the tsunami which occurred in the Indian Ocean in December 2004. Occurrence of an earthquake. As seen from the diagram, Earth is made up of the crust, mantle, outer core, and inner core. The outermost layer of the earth is not one continuous piece, but it is made up of many pieces called plates. Due to the slow movements inside the earth, these plates move with respect to one another. Crust, mantle, outer core, inner core. The surface of the earth is divided into 7 large plates and several small plates. Most earthquakes take place at the boundaries where the plates meet, though they may also occur within the plates. The plates brush against one another, or at times a plate may go under another plate due to collision. This causes disturbance in the Earth's crust. This disturbance shows up as an earthquake on the surface of the Earth. Earthquakes are also caused due to volcanic eruptions. The energy released during a volcanic eruption causes vibrations in the crust, which in turn causes earthquakes. Earthquakes may also occur when a meteor hits the earth or due to underground nuclear explosions. Most common cause of earthquakes is the movement of Earth's plates. The boundaries of the plates are weak zones where earthquakes mostly occur. These weak zones are called seismic or fault zones. In India, the seismic fault zones are Kashmir, Western and Central Himalayas, whole of northeastern region, Rajasthan, Indo-Gangetic Plain, and Rann of Kutch. The magnitude of an earthquake is measured by the Richter scale. An earthquake having a magnitude of 2 to 4 on the Richter scale is not damaging. Magnitude between 4 to 7 is considered moderate, and that above 7 is destructive. Do you know that an earthquake of magnitude 5 is 10 times more severe than that of magnitude 4? Activity. With the help of internet, find out 2 earthquakes which occurred in India having magnitude of more than 7.5. The vibrations caused by an earthquake travel in the form of waves on the surface of the earth. These waves are called seismic waves. Seismograph is an instrument which is used to measure seismic waves. It consists of a vibrating rod or pendulum with a string to which a pen is attached. The rod starts vibrating when tremors occur. The seismic waves are recorded by the pen on a paper, like graph, which moves underneath it. The point of origin of the earthquake inside the crust is called its focus. The point on the surface of the earth vertically above the focus is called the epicenter. The branch of science which deals with the study of earthquakes is called seismology. The scientists who study the behavior of earthquakes are called seismologists. Effects of the earthquake. Some effects of the earthquake are as follows. Earthquakes cause deformation of the ground and enormous damage to buildings, roads, bridges, etc. It can also cause loss of lives in large number. Electric poles get uprooted and telephone wires are damaged. The collapse of the sewer system leads to spread of diseases. Strong vibrations may also lead to spread of fire in houses, mines and factories due to electrical short circuit and bursting of gas cylinders. Tremors in the hilly and mountainous areas cause landslides which damage settlements and transportation infrastructure. Protection against earthquakes. As we know that occurrence of an earthquake cannot be predicted, therefore, we must be ready to protect ourselves all the time. People living in the seismic zones need to be specially prepared. Buildings should be designed so as to make them earthquake-proof. The building must be made earthquake-resistant as most of the damage is caused due to falling down of buildings. Keep roofs as light as possible. This will minimize the damage due to building collapse. Cupboards and shelves must be fixed to the wall. Ceiling fans, air conditioners, and coolers must be secured firmly. They can cause a lot of damage if they fall down. Wall hangings, wall clocks, photo frames, etc. must be hung carefully so that they may not fall on people in case of an earthquake. All buildings must have firefighting equipment in working order at all times to extinguish the fire caused during an earthquake. In case of an earthquake, the following steps need to be taken. At home, take shelter under a sturdy object like a table or a cot. Stay there till shaking stops. Stay away from tall heavy objects that might fall. When outdoors, move away from buildings, electric poles, and trees which might fall down. Stand away from overhead power lines. If you are in a vehicle, stay inside till tremors stop. Drive slowly to a clear area, away from bridges, tunnels, trees, power lines, electric poles, signboards, etc.